Welcome again to this recording of the aspect of biostatistics. Today we're going to be discussing instrument development. Instrument development. So I welcome you warmly to this tutorial that will provide you some understanding of how instrument for data collection is developed based on certain theoretical and conceptual consideration. So let's go to this right now. All right, so the title of this presentation is An Introduction to Instrument Development for Data Collection in Research. Okay, so let's look at the outline. We're going to say that 4 areas of consideration at this time. We have the first question: what is the philosophy involved in the research process? We're going to look at that so that we'll be able to identify the basis of our measurement. If it is an observational study, the measurement is different. If it's an intervention experimental study, the philosophy and the measurement is also different. So what is measurement in research? So we want to look at what we are measuring and what's the meaning of measurement. Then how is measurement conducted? And then we are going to look at how is the measurement reported or interpreted and reported. I've given you assignment to develop an instrument for measuring certain characteristics. And it seems that most of you do not understand what it takes. So I've been revising your submission. So this video will help you to grasp the concept of measurement, and then how it relates to all the things I've been asking you to consider: theories, concepts, the title itself. But some of you are thinking that you are going to write a dissertation or a thesis. No, you're developing an instrument for data collection under the course Advanced Biostatistics. And so you're not writing your thesis or your dissertation. You're only developing an instrument. And so the foundation of that instrument development is very important in the consideration of that activity. So let's go now. So let's quickly look at the philosophy involved in the research process. Research involves relentless inquiry to ascertain verifiable truth about natural phenomena. Yes, that is what research is. Searching. Search again. Search. Research. Look again. Because in the first attempt, in the first activity, you may have missed something. And most times we are missing a lot. And that's why research is ongoing. What we found 10 years ago requires updating, because maybe 10 years ago there are certain limitations we had. We didn't discover everything. But with knowledge increase in the field of study, we are able to advance our technique for searching again. Now, 2 important approaches are there. We have quantitative approach and we have qualitative approach. So it depends on which approach you're taking to develop your instruments, and the philosophy also. They are different. Research, yes, common to both, but whether it is quantitative or qualitative, again, approaches will define what you are going to be doing. Now, there are 2 basic designs in research. We have the experimental design and we have the observational design. Now, These two designs are also identified based on the titles they bear, the research questions raised, objectives, and measurements involved. These are specific for the design, for the various design. So the design for experimental study will have its own title, style. The research question raised is different. Objectives that are set or course of action set to capture the data involved, they're different. And the type of measurement that is carried out in the experimental or observational studies are different. All right, they're specific to their design. So you don't just create a title anyhow. The title reflects the design, and the design reflects the question raised, the objectives, and the measurement, and the type of data that is collected and organized and analyzed. So we need to differentiate between experimental and observational design. Observational research differs significantly from experimental design research. So there are major differences include that the title differ. For experimental design, the title indicates treatment, all right? So for experimental design, the treatment is the focus, all right? The treatment is the focus. Whereas for the observational design, association is what is desired. We want to identify the types of association that exist that is driving the problem phenomenon. So if you have treatment in mind, association will not be applicable. Treatment design will want to see how good the treatment is. So your title, from the title, the difference begins to appear. So the title for an experimental design focuses on treatment, whereas for observational design, like a cross-sectional design, associations are desired. We want to identify the types of association that exist and predictors of the final, the output or the outcome variable. Questions raised are different also. For experimental design, the question raised focus on the treatment, all right? And the observational design focus on samples' ability to predict the population characteristics. So in the experimental design, we are testing the efficacy of the treatment that has been developed. Whereas in the observational study, the samples that we have drawn from the population is what we are questioning, whether it is able to predict the population characteristic exactly, or there are errors. So that will carry its own philosophy, whereas experimental design or interventional design will carry its own philosophy along the title, question raised, even the specific objectives. The objectives for these two differ as well. So the objectives attempt to answer the research question, right? And the research questions are different. So you find that the research question is asking the question about the ability of the treatment to change, to effect a change, to impact the problem phenomenon. Whereas the research question in observational study is asking whether there is a connection between the independent variable, the explanatory variable, and the outcome variable. And therefore, your specific objective is going to be structured in such a way to answer that question. And that will now involve measurements, because every empirical study conducts a measurement, carries out measurement that will quantify. And that's why empirical studies are referred to as quantitative, qualitative. All right, so measurements involved in these two differ as well. So In the experimental design, we are trying to measure the effects of the treatment. All right. And in observational study typified by cross-sectional design, attempts to measure the extent to which the samples selected predict population from which they are derived. So let's look at what measurement is. What is measurement in research? Because every research that does not measure is only a review. Reviews do not measure, only provide perspectives, interpretation, and conclusions. And so an empirical study will measure. And so the answer to what is measurement in research is that the process of assigning number value to represent the amount of characteristics or properties possessed by an object, a phenomenon, or a program. And therefore, if you're going to measure, you have to develop your instrument. So measurement goes with instrument. And this is why this video has been designed. All the philosophies that we are talking about only boils down to we're measuring. What are you measuring is the question. And whatever you are measuring has to deal with the phenomenon being considered. And therefore, we have some examples here. Let's say your study wishes to measure weight or height of individual or other characteristics such as satisfaction, which is it's a construct. Knowledge is a construct about a phenomenon. Then we need to develop instruments that would measure these very effectively. And to measure weight and height, we require specific types of instruments to do that effectively. So developing instruments do this differ, but both of them have the same function to quantify. So measuring weight or height, or measuring satisfaction, level of satisfaction, or level of knowledge about a particular phenomenon will be considered differently because the first two, weight and height, are scientifically constructed. All right, weight and height, the construct weight and height is scientific. It goes with force, the physics of matter. All right, already we have instruments that are developed to measure weight, and we have instruments that are developed to measure height. But when it comes to such characteristics like satisfaction of individuals towards service provided, then you have to develop your instrument. You have to construct the instrument satisfaction. And to construct such instrument, you must delve into the theory underpinning satisfaction. Likewise, knowledge. Knowledge, you have to use the theory and concept in cognition to develop the construct knowledge about any phenomenon. All right, so I hope you are beginning to appreciate this. So measurement of weight or height of individual will require scientific instrument, which already has been validated and the reliability assured. All right, and is accurate only if the reader, the user of such instrument, is careful and understands how it is used. Measurement of characteristics such as satisfaction, as I've explained, knowledge about phenomena, including perception, values, health belief, and so many of these constructs that we use in health and health sciences will require that the researcher develop an instrument that will measure this. And usually the instrument that will do this is referred to as paper pencil instrument. And therefore it requires to ensure validity and reliability, just as the scientific instrument has been validated and the reliability also assured. So these are two activities that the user of paper pencil instrument needs to do. The scientist, the researcher has developed an instrument to measure satisfaction. Then validity and reliability needs to be clearly ensured. So we need to understand the level of validity and also the level of reliability that the instrument, which is quite intense when you have to engage in this. So how is measurement conducted? So we start off with development of an appropriate instrument, and that will help us. Most often we use the paper pencil instrument for measuring characteristics in social sciences, in health sciences, and the researcher himself or herself will develop these instruments. The scientific instruments are rigorously developed. They undergo rigorous validation and also rigorous reliability tests to assure the level of reliability. And reliability simply means how consistent the instrument will measure a single property. How consistent will the instrument measure a single property on repeated use, on repeated measurement? So if the measurement fluctuates, you provide you different measurements at different times, then the instrument is not reliable. And validity simply means how true is the instrument measuring what it claims it will measure. And so these are the two burdens of the researcher in health sciences and social science in terms of validity and reliability of the instrument they are developing. There are resources required to do this activity, to assure validity and reliability. An alignment between the problem phenomenon through the research questions raised, objectives, mapping out course of action to take in answering the research question, the hypothesis, and the conceptual framework. These are resources required. And that's why in the concept paper that I gave all of you to use, I was emphasizing on the alignment between the problem phenomenon that you have identified, the research question raised, the objective set, the hypothesis, and the conceptual framework. The conceptual framework derives its resources from the literature that confirms the nature of the disease, the problem phenomenon, the theoretical framework that underpin the dynamics of the problem phenomenon, which provides the conceptual framework, which is the blueprint to design everything about the research, and including the instrument, because the instrument must follow the instruction embedded in the conceptual framework for it to be valid. Because if the instrument is not well aligned with the thesis is the problem phenomenon, the research question raised, the objective setting out the course of action to take in answering the research question, the hypothesis, and the conceptual framework. These constitute the thesis of your argument. And if there is no alignment, no suitable alignment, then it's likely that the instrument you're going to develop will not be aligned with the data that will be derived. The data that you are going to collect with the instrument must align with your hypothesis. Any inconsistency in alignment will create some problems with the final conclusion of measurement. Now, the alignment between the problem, research question, objective, hypothesis, conceptual framework helps the researcher to develop the instrument. The conceptual framework is the blueprint to guide the development of the instrument. And every aspect that we have talked about, all the theoretical issues that we have mentioned, the conceptual clarification, they are all resources used to develop the conceptual framework, which is now referred to as the blueprint to guide the development of the instrument. So if there is poor alignment, the instrument is poorly developed, the data that you're collecting will turn out to not to support your research hypothesis. Now, the data to be analyzed should provide support for the thesis in the study. Otherwise, there is no justification to engage in the study at all. So this is what we mean by conceptual framework. It's a visual representation of the dynamics of the problem phenomenon. And it also represents the variables in the study. And that's why I mentioned that the theoretical framework provides the resources for developing the conceptual framework. And the conceptual framework must align with the theoretical framework. And that theoretical framework attempts to elucidate the dynamics of the problem phenomenon. So we have a conceptual framework here we consider a linear model. A linear model, we have the ABC, we usually call this the ABC. All right, so the A is the antecedent variable that we call the explanatory variable. The explanatory variable consists of two major sources of the variables. We have the what we call the independent variable, and the moderating variable makes up the explanatory variable. So these are the factors. So within the antecedent variable or the explanatory variable, we have the factors that will predict the outcome. And here we have the outcome, primary independent variable. We may have two outcomes. We usually have, when we have two outcomes, one becomes primary and the second becomes secondary outcome. But here we are illustrating the outcome or the dependent variable as primary. So we have the antecedent variable, explanatory variable, connected with the primary dependent variable or the outcome variable, and then the outcome variable results to consequences. So we can see this as diagnostic. So if we want to understand the dynamics involved in a particular outcome consequence, we have to look behind. We have to look at the primary dependent variable and see how it comes out, and then the antecedent that creates the primary dependent variable. All right, so we've seen this and we have explained this, that from the conceptual framework to the instrument. The conceptual framework operationalizes the principles underpinning the natural phenomenon in an attempt to explain the dynamics. So this conceptual framework is very important in facilitating understanding the dynamics involved. And so as a blueprint, if you follow it, you should be able to explain what is actually happening. And in research, we're not just trying to answer the question, what is happening? What is happening? Most times our research starts and ends with answering the question, what is happening? What disease is it? What's the nature of the disease? And we forget that research goes beyond what is happening. Research attempts to understand why is what is happening. And further, the research needs to explain how, elucidate the dynamics of the problem phenomenon. All right, so research is not simply answering the question, what is happening? Research further explains why and how these things are happening. Now we have a more complex framework here, where we have the two antecedent constructs, all right, parallel and connected with behavioral outcome. So the two antecedents, A and B, are in explanatory variable. They explain why this behavior is occurring. And the quantity of these antecedents are measured. There are measurements that you conduct. You want to measure how much of antecedent A is there and how much antecedent B is there. And we want to also measure how much the behavioral outcome is there. You quantify. That's why the research is quantitative. And then there are other tools that we use in statistics to see how these are connected with each other and be able to explain the dynamics. All right, so these arrows are indicating the dynamics involved. And then we have the consequence. In most cases, consequences in health sciences and social sciences will be the social issues, poverty, and so on. But in health sciences, the prevalence of particular disease are constant. The disease is a consequence of a particular behavior, and we want to quantify this disease using epidemiological principles. All right. So in behavioral, we use health promotion principles and public health principles to tie everything together. So your instrument is designed in such a way that it will collect data that can be quantified in terms of mean of whatever antecedent, standard deviation, standard error of the mean. And this is what we mean by statistics. Collect the data, organize the data, analyze the data. It is during analysis that you begin to synthesize beyond just what you have. In the applied biostatistics that we're doing alongside, we're talking about the use of computer-assisted statistical software like the IBM SPSS. We can see that it's not only responses that you are measuring, you're capturing, you are translating the responses into quantitative measures. These are advanced level of applied statistical analysis in the use of computer-assisted softwares like SPSS. All right, so from the conceptual framework, we have seen that you can have different structures, but they have to flow from left to right. The backside will be the antecedent. Next will be the outcome and consequences. So that's why we have it as ABC. The previous one was linear. This one is more complex than the linear one. Right, so questionnaire developed and tested. How do we do that? We develop our questionnaire based on the conceptual framework. Once the conceptual framework has been well constructed from the theoretical framework, the concept underpinning the problem phenomena, we develop our questionnaire. Questionnaire, they're not really questions all the time. There may be statements, but it requires that the respondent selects an option that pertains to his or her experience. We're not testing the respondent's intelligence. We're testing the respondent. We're capturing the respondent's experience. All right. So the items that we have used in developing a questionnaire are the response item that the respondent will respond to those item statements. Those items are now coded and entered into the computer running the statistical product and service solution, which is the SPSS. Today, we do not refer to it again as statistical package for social sciences. No, that name ceased to be sometime in 2011, 2012, when IBM bought over the company that initially produced the SPSS. But to retain the SPSS being so popularly and globally known, they had to use an acronym and name that will retain the acronym. So today we know it as Statistical Product and Service Solution. All right. So we first of all run frequency distribution. We follow that with conducting weighted aggregate scores for the responses that the respondent has in order to generate what we call the latent variables in the study. The latent variables are the sections of your questionnaire. For example, knowledge. All right. In the knowledge we're trying to operationalize with the items, they are latent at the time. But by the time we do our analysis and synthesis, we now synthesize the variables in the study. And we now synthesize it based on aggregate, weighted aggregate scores for which the individuals have responded. For instance, excuse me, in knowledge, we can have a yes, no. All right. In knowledge, you can have a yes, no. Or for attitude, perception, and all those that have to do with your mental state, responses, right? And your thinking. We use strongly agreed. These are the like it type responses. Strongly agreed, agreed, disagreed, and strongly disagreed. Or for behavior, we use not at all, which is most appropriate to capture the frequency of behavior. Not at all, rarely, occasionally, and always. So these are appropriate responses for behavior or practice. You practice something, not at all, or rarely, or occasionally, or always. You wash your hand, not at all. You know what that means. Rarely, you know what that translates to. Occasionally, you understand what that translates to. Always, again, you understand what that translates. So there is a delineation in the frequency of performing a particular behavior or practice. It's important that we note this. So we don't use strongly agreed for behavior. Behavior strongly agreed will be for mental dispositions of attitude, belief, and perception. Now, the various components of the conceptual framework must be represented in the instrument development. So while developing your instrument, you must have at the back of your mind the components of the conceptual framework. The antecedent variable, you set them. The what do you call it? The explanatory variable, you set them. The outcome variable, dependent variable, you set them separately. And if you want to add the consequences, you set them too and measure them as well, accurately too. All right, so we have in the structure of a typical questionnaire, we have the section A that refers to demographic characteristics. Remember, this is the true independent variable because nothing develops them. They are what they are. Nothing creates them. A male is a male. A female is a female. Gender, educational attainment, age, and all of that, they are demographic. So you have the next section, usually level of the antecedent in the conceptual framework. So this time we're now going to create, that's why we call this antecedent a construct. You're going to construct that using items. So the respondent will respond to those items. Now, those items must be consistent with the theory underpinning the construct. So these are some of the rigors involved in creating instruments. Then you have the section C, level of another antecedent. So if you have 2 or 3 antecedents, each one would belong to a different section. For instance, if you are doing a CAP study now, a KAP study, so the first antecedent will be the K, the second antecedent will be an A, the KA, and then the third antecedent is going to be the P. P for perception, not practice. KAP, knowledge, attitude, and perception regarding a particular behavior, because the KAP for behavior is a diagnostic tool in public health research. It's commonly used as a diagnostic. So now you have the level of behavior of interest, which is the last aspect. So the last aspect is the behavior, which now creates the disease. So now the section E is a disease, and to measure disease, we usually use prevalence of the disease in the community or among those who have been selected. All right, so in chapter 4, we talk about the report. This is where you write your report of what you have identified. All right, so frequency distribution is reported first. Then the synthesis of latent variable, that's the sections, not the items now. The items came under frequency distribution. So in further analysis and synthesis of your data, you are going to create latent variables from the response item, which operationalize the latent variables. For instance, in knowledge section, you have items there, and those items will now operationalize the knowledge itself. So this is what we are practicing now in the applied biostatistics. So variables in the study which were latent are real. All right, they are real, but at the time of the collection of the data, they are not there. At the time of analysis or entering the data into your system, into your laptops and computer, they are still not there. It is when you now synthesize them as weighted aggregate scores for each respondent in the study that they emerge. They emerge to describe what is happening, the level of knowledge, the level of attitude, the level of perception. How does it connect with the level of behavior? All right. So that is how it's done. Now, these are some of the examples of frequency distribution and the graphs. This is how they are represented in the report. So you can either use a table or use a graph. You cannot use a table for the same thing and a graph for the same. It's double reporting. It's not decent. It's wrong. So either you choose to use a table, frequency distribution table, or use a pictorial like a graph like this. This is also a frequency distribution. All right. Okay. So now measurement has been conducted, not just count, and we have reported them. I believe you are going to do better than what you are doing now. Thank you for listening. You can go back to look at this video again, and if you have any issues, contact me and we will discuss further. Thank you and bye-bye.